Alright, now let's turn our attention to a problem from section 4.5. In section 4.5, problem number 16, you are asked to determine between which consecutive integers the real zeros of each function are located. And in particular, on number 16, the function we are given is f of x equals x to the third minus 3x plus 1. Now, you learned in this section or the previous section about Descartes' rule of signs. In my experience, that actually is more confusing than it is helpful. So I would actually recommend that you not use Descartes' rule of signs. Here's what I would do instead. I would find just a whole bunch of function values, meaning plug numbers into the function and see what happens. So I'm just choosing to plug in -2, -1, 0, 1, and 2. Alright, now I did this work ahead of time. You can plug the numbers into the function and do the math yourself, or you could use the remainder theorem as we mentioned in section 4.3 and use synthetic division instead of plugging numbers into a function, and then you would avoid having to use exponents if you use that. Okay, well, let's see what happens. When we plug in -2, you should get -1 coming out. So -2 to the third is -8. -3 times -2 is +6. So -8 plus 6 is -2 plus 1. That's how you get -1 if you're just plugging the number in. I'm not going to go through all the steps for all of these, but if you plug in -1, you should get 3. If you plug in 0, you get 1. If you plug in +1, -1 will be what comes out, and if you plug in +2, you should get +3. Okay, so what we discover is that the function values go from a negative to a positive somewhere in between -2 and -1. So that tells me that there is a 0 somewhere in the interval between -2 and 1. So a 0 should have the word in. So somewhere in between the numbers -2 and -1, there is some number that you can plug in that will come out to give you 0. Similarly, here we see that we have +1 coming out when we plugged in 0 and -1 coming out when we plugged in 1. So since one of those is positive and one of those is negative, there must be a 0 somewhere in that interval, and in this case the interval is the numbers that we plugged in ranging from 0 to 1. And then finally we see that it goes from -1 to +3 here, and so there must be a 0 somewhere in between the numbers that we plugged in. In this case we plugged in the numbers 1 and 2. So this gives us the consecutive integers wherein our real zeros will be located. So somewhere in this pair of consecutive integers, somewhere in this pair, and somewhere in this pair, we have 3 zeros. And in addition to that, since the power, the highest power of x in the variables of this function is 3, we know that there cannot be more than 3 zeros for this polynomial. So then we know we've found all of them.